Cry. So what happens here is that we have our two zeros, or two side lengths, I should say, of the x plus 2, x plus 3. And then the other side length, the hypotenuse, is 29, because it was given to you saying that it is the longest side length. So you write it out. The quantity, x plus 2 squared, plus x plus 3 quantity squared, equals 29 squared. Now, we have two sets of what we call junk squared, which means it's going to be junk times junk plus junk times junk. Rewrite it out. Bless you. Bless you. And whatever 29 squared is, I don't know. Okay? You need paper? You're going to want to write this out.
This is number 20?
You cannot fit this on that sheet.
See, this is number 20.
So now again, go through and FOIL it. Show your arrows if you're not exactly sure on where you're going with everything. First, outside, inside, last. X squared, 2x, 2x, and a 4.
Oh, you don't feel like the first x in the first one, the other x in the other two. Wait, never mind,
Good conversation.
No.
And then I do it again. All right? First, outside, inside, last. Do you remember the pattern? Nice.
Yeah, he figured it out yesterday.
Nice. So now, you just combine like terms. I'm going to do that in 2 steps. I'm not without trying to do like too much at once for you guys. Actually, this one I can do it all at once, right? Is it okay? I have an x squared, and an x squared is how much? 2x squared. 2x, 3x is 5. 2x, 3x is 5, so it's 10x. 4 and 9 is 13. Are we all in agreement that we're going to have to move that 29 back to the left to set aside equal to 0?
Yeah.
So what's 20? Yeah, we're going to have to do that in order to set aside equal to 0. So what's 29 squared?
841.
841? Okay. So all I've done there is move the 29 over. Yes?
3 should be 13.
Yes.
Make sure it's 41.
I thought I did that. All right. We okay now?
Yeah.
What's 13 minus 841?
828.
No, it's only 85.
That's almost.
Oh my gosh.
It's not even 8 o'clock.
It's like bad dad jokes.
It is, it's bad.
It's like that. It's like
All right. Now you're at a quadratic equation. Now, yesterday what we said is that if I were you, I would simplify it now. Because if you noticed, all 3 of those terms, they're all divisible by 2. But do you really have to? No, you really don't, because you're going to use a calculator to figure the rest of the stuff out. The only reason that I do is because it just makes the numbers a little bit easier to work with. It doesn't seem as daunting, it doesn't seem as scary. Is it the right
I already don't want to solve
She absolutely.
functions.
Thank you. You know, you're a good person.
Where it doesn't make sense. Right.
So I'm just going to simplify them all by 2 just because I can. I get x squared, a 5x, and a 414. Now it's in the format of a quadratic equation. ax squared plus bx plus c. So if you're still having troubles about what goes where, take 2 seconds and list them. List what is your a value. My a value is 1. Why is it 1? Because that's the coefficient of x squared. We just don't write the 1 down. Okay? It's one of those math etiquette things. Our b value is 5, and our c value is negative 414. So far, so good?
What if you just left it out of the 2 guys?
then your A value would have been 2, 10, and negative 828. You're still going to get the same result in the long run. I just wrote it because whenever I see something I can simplify, I just do it.
Because I always forget to say.
And that's okay. If you did this correctly, you're going to get the exact same answer.
If you look on the backboard, I did number 19, and when we did number 19, we chose not to simplify the A, B, and C. We kept them 2, negative 16, negative 1,536, plugged it into the quadratic, and we got it to work.
Yeah, it still works, guys. It's just I'm from back in the day when we didn't have these fancy things called calculators. We had to do this work by hand. We had to figure out what times what was 414 that you had to get 5.
Don't make me fun of Mr. Rowe.
I'm not. We're not that far apart in age.
Who just said that?
Really?
Really? You're not old enough to be my mom.
I'm old enough to be.
Your sister. You'd be like my older sister.
Okay.
How old are you?
Old enough.
Doesn't even look old though.
She
Mr. Rowe's
doesn't.
32 and Mr. Rowe.
I'm
33.
greater than 50.
You're older than 50?
No,
Oh, you're
I'm-
surprised?
32.
Are you surprised, Kevin?
Yeah, I mean, I'm still 15, so
It's not like you.
second of all,
My mom's 14.
My mom's 40.
Uh-huh.
everyone's mom is
My mom's 53. She's old woman. She's old enough to be my grandma. My mom's old enough to be my grandma.
All right, here we go. Fill in the blanks. Come on, guys. Fill in the blanks. We start filling the blanks. What's opposite of a positive 5? And then I write down 5 squared minus 4 times 1 times negative 414 all over 2 times 1.
Oh my god.
Again,
to
you
put it
have-
2 times 1.
No, you don't have to. You can stretch it. And it's fine. It's habit,
Oh.
and I write it out because that way it helps. It forces me to remember what the formula is. Because
Alright.
sometimes if you continue to do that and not write down the times 1, if there happens to be an A value that, let's say it's negative 1, you'll forget it. See what I'm saying? If you're not careful about that, you could skip your A value by not writing it down. So by writing it down every time, it'll force you to always remember that it's there. That's all. It's just practicing.
Oh.
You know what I mean? It's in case you need it.
Sorry.
So we talked about this yesterday. Don't ever try to type all this into a calculator. There is no such thing as a plus minus button. People have always asked that. Where's the plus minus button? Well, there isn't one, so it doesn't work. What you want to do is you type in the stuff underneath the radical. That stuff underneath the radical is called the discriminant. Okay, if you remember that from last year. The discriminant serves a lot of different purposes. You'll learn more and more about that next year in Algebra 2. But for right now, I'm just going to type in this. When I do that, please and thank you. I get 5 squared minus 4 times 1 times negative 414. I get 1681.
Yeah.
Now I take the square root of that. Second square root of my answer, and I get 41.
Awesome.
All that work for 41, yes. So, I have negative 5 plus or minus 41 divided by 2. Which means it's going to give me 2 separate possible answers. I have negative 5 plus 41 divided by 2, or negative 5 minus 41 divided by 2.
36. Negative. No.
Remember what we're looking for here, guys. We're looking for values of x that will create side lengths. If I use a value of x, let's see, negative 5 and 41 is 36. What's half of 36?
18.
18. So this one gives me 18. The other one I get negative 5 minus 46,
Negative
41.
46.
Divided by 2.
Divide that by 2, you get negative 23. Now, this problem said your 2 side lengths were x plus 2, x plus 3. I have a negative 23. Will that work for a side length then? No. So I know that this one won't work. So my only answer is no. Unfortunately, no.
So we literally did all this. Just to get.
Yeah, what's happening is that when you use
Well, like
18,
$18
it's just a matter of just
No,
putting it
I
out.
want-
You still,
We came to school to get paid every
when you're finding the value X that's making for
I would come to school every day. I would get
Yeah, unfortunately, guys, there is no shortcut to any of this. There really isn't. I mean, I guess if you really wanted to, you could probably go through and list your factors of negative 414 that add together, give you 5. I mean, if it was a smaller C value, yeah, I factor it by hand. But since basically all the examples we've done have had larger values of C, it might be a better choice to do it this way. Okay? Very exciting.
Yup.
Very, very exciting. Yay! All right, well, hold this for right now because we're going to add to it. I got a couple more examples to show you guys, but I need you to have a piece of graph paper.
Stole my gun.
Show you guys a couple of different other things that are the hurts, the pain, the shame. Yes, ma'am. We need another one? You got a spare? Because I don't know how to count.
I just wake up.
So here's what I want to do. Sometimes sometimes you're going to be given ordered pairs. Sometimes we're going to be given ordered pairs, and we're going to need to decipher what type of a triangle it's going to be created. Is it going to be acute, obtuse, or a right triangle, given the ordered pair values? Now, what happens here is that this is going to wind up being a little bit more of an exercise on remembering where your X and Y values go, how to plot them correctly. Because I've been kind of surprised at how many of you guys have forgotten how to plot ordered pairs.
go up and do this?
1 sec, please. Just give me 1 sec, all right? Now, real quick, which one is the x-axis? The left and right or up and down?
Left and right.
Left and right. Which is the y-axis?
Up and down.
The up and down. So, when you have an ordered pair, what comes first? X or y?
X.
Do you know why that is?
Because X is stronger than Y.
No, just think of the alphabet. Doesn't X come before y?
That's why I said
Yeah, that's all. So, if I'm looking at this -8, -4, that means I go left to -8 and down to -4.
Do you want us to do this?
Yes, please. There's our first one. Yeah, that's why I get graph paper. Now I have -5, -2. -5, -2. -1, -7. So I have these values, to figure out. Now remember, the easiest way to tell side lengths, block them, come on, don't just stand there or sit there. The easiest way to tell side lengths is to use Pythagorean theorem. Because we're on a grid, because we're on there, so you've gone 25 minutes, you don't have this. Come on.
My boy.
Now, when you do this, here's my suggestion. You've got your stuff plotted. Since you're on a grid, this makes so much sense. You go up 2 right 1, 2, 3. So you went up 2, right 3. So that means this part here becomes a hypotenuse. So in your calculator, what's 2 squared plus 3 squared?
It will be
13.
equals to 8.
It's 13.
Wow, that was really.
So that means
small.
that the side length here is the square root of 13. Here's that right there. Don't worry about decimals. Well, we're going to do this in all simplified square root form because it's going to be easier. Okay? Because you won't have to worry about rounding errors then. Okay? I do it again. I go over 1, 2, 3, 4. I went over 4, and I went down 1, 2, 3, 4, 5.
I see what we're making now.
I've made another right triangle. This becomes a hypotenuse. 4 squared plus 5 squared. Well, 16 and 25 is 41. That means that hypotenuse is the square root of 41. Lastly, I went over 1, 2, 3, 4, 5, 6, 7. And I went up 1, 2, 3.
7.
So I get 7 squared
9.
plus 3 squared, so it's 49 and 9 is 58. So now you have 3 side lengths to check, like you did yesterday. Square root of 13, square root of 41, and square root of 58. Which of those 3 is the largest?
58.
The 58. Even though it has a radical, it still would work. So now what you do is, well, is the square root of 58 relationship-wise with root 13 and root 41, and we're just going to square all of them.
Yes, they are.
And the square root of any number squared is?
Yes, ma'am.
I'm just using the basic. Oh, that looks
So now you get 58. Here you have 54. So since this one's bigger, what kind of a triangle is it? Obtuse, very good. All right, so you get obtuse.
Why don't you just give us the graph to do it on?
What's that?
Why don't you just give us the graph to do it?
No, you just plot it.
So it would make it like
True, but you can't assume. Because then you'll make an angle side to side out of you and me.
That was.
Let's do another one. All right, wait, sorry. I'm sorry.
This number
Sorry.
says
Well, we are, so there you go. Well, we are, so.
Say it, I dare you. I dare you. I dare you.
All right, you ready?
No, I
This
wouldn't.
morning, I went in, I was shooting around. I told you to active. I'm at least scoring 20 points. Off just for these.
All right, here we go.
Some layups.
First one.
I don't know. They were not practicing. I hope.
Let's do these 3 ordered pairs again. So we have -2 and 4,
I said I can do this one.
6 and 0, -5 and -2. Okay. So plot them. Okay. We start by plotting them. Remember x's and y's. So we have -2 and 4, so I go over to the left 2 and I go up 4. 6 and 0, it's on the x-axis. And then -5 and -2, right here. And now I'm going to connect those 3. So now, just like we did a minute ago, let's count our vertical and our horizontals so we can figure out that hypotenuse part. So let's count. Ready? 1 little, 2 little, 3 little, 5. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6. I went up 6, and I'm going to go over 1 little, 2 little, 3. So now I take 6 squared plus 3 squared, so it's 36 and 9, which is 45. Now, is it okay if I just write down it's going to be the square root of 45 here?
Yeah.
Because if you use your calculator and simplify it, you're going to get 3 root 5. What I'm doing here is I'm kind of shortcutting. Let me show you what I'm doing. I'm taking 3 squared plus 6 squared, and this is just going to equal 45, and I know that I have to take the square root of it. So sometimes you don't, since we're not trying to get an exact answer here, and I wanted to be able to look at the relationships between all the side lengths, it's perfectly fine to leave it with that radical in there. Because when you're just going to square it in a second anyway. So I do it again, that counts. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8. And, 1 little, 2 little, 3 little spots, 4. So I have 8 squared, 4 squared, so it's 64 and 16.
Yeah. You get 78. No. You get 80.
Yeah, right, yeah. So it'll be root 80 here. And then lastly, just count the other one. Down 2. Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
No.
So 11 squared. So 121 and 4 is 125, I believe. So now, by not simplifying your radicals, it's easy to compare each of those side lengths via just the square roots. I don't have to look at them I don't have to look at it any differently. Yes, ma'am.
So like if you're going down, you don't have to do this.
No, because we're counting distances. Distances are always positive. Okay. So now, by doing this, obviously the root 125 has to be the largest. Bless you. So, is root 125 relationship between root 80 and root 45? So if I square these, what's the square root of 125 squared? What's 80 and 45?
We even have to write the square root of
What's that?
We have to write the square root of
I would just be, I want you to know that what you're doing. You're just, because basically you're just using Pythagorean like 4 times. Okay. So what kind of triangle is it?
Just add those together. That's all you get.
Yeah, it's the right choice.
Nah, I see now.
So, as you see, yes ma'am? Yeah. Yeah, because what you're doing here is, when you're on a grid, the easiest thing to follow through on is the vertical to the horizontal, which creates the diagonal. Yeah. So you can use, basically what we're doing here is we're using distance formula without using distance formula.
I like that.
Yeah, because the distance formula is nothing but Pythagorean theorem. Because you can do the distance between these 2 points, and you're going to get the square root of 45. But isn't it easier, instead of writing out that whole formula, just to count up and over? Much easier. In essence, it's the exact same thing.
So this is
This is the shortcut. Pythagorean theorem is, if you have a graph, Pythagorean theorem is much quicker to use than the distance formula, but there is a time and a place for distance formula. Okay. Good. Do those graphs for Monday.
Real.
Yeah. You might have done one of them already. I've been known to help you out from time to time.
Yeah, last night we did like 4 solid.
Gee, you think?
I was like, oh.
So, but you know what that tells me? That just tells me that you actually went back and looked at your notes to help you with the homework.
I did.
This is what you're supposed to do.
Go figure.
And then I found all the answers. You already got it?
know this.
Yeah, just those 6 right there, please. Yes, sir.
Is it okay if we write these problems on this paper?
Absolutely. Yeah, guys, if you want, because actually, you know what? That's a really good idea. Why don't you do that? Because why don't you do these graphs on the graph paper I gave you? Because they're going to fit so much better. You don't have to worry about the scale, because a lot of these things are going by 2s and stuff. That's fine. But if you haven't done that yet, if you haven't done these 6 in the middle here, use the graph paper I gave you. It's going to be easier. Okay?
Okay.
Thank you for saying that. I
Should I
totally
write
forgot
the
about
answers on these
that.
things?
Yeah, that's fine. All right.
Time.